Ma'am,
Yes.
ma'am, I have a question. What is assay?
Assay means to determine the percentage purity. Clear?
Yes, ma'am.
Is it visible to you? The PPT?
Yes. Yes, ma'am.
Okay, ma'am. So again, we will continue. This PPT will be the continuation for your Muhur's method, and the next method, that is the Pajan's method. Okay, now some basic terms have been explained in this PPT, like what is the concept of precipitation titration. Now, the concept of precipitation titration is based on the solubility product. Okay, I think you have come across the term solubility product, law of mass action in your physical chemistry. Am I right or wrong?
Yes, ma'am.
Yes. So you already know about the law of mass action, then solubility product. So this precipitation titration is actually conceptualized from this law of mass action. So an example has been shown to you. For example, we have taken a salt Ba. So when this salt Ba dissociates, it dissociates into positively charged Ba plus and negatively charged A minus. So when you are applying law of mass action to this salt, dissociation of this salt, which is being denoted by the constant K, that will be denoted as K equal to B plus into A minus divided by Ba. Now K is the dissociation constant. So this law of mass action actually helps in the conceptualization of the precipitation titration. That means in case of precipitation titration, if you want to find out the concentration of the precipitate of any ions, you can find out by applying the law of mass action. For example, take the example of okay. So NaCl will dissociate into Na plus and
Cl minus.
Cl minus. So if you apply law of mass action to this dissociation of NaCl, so what will be the formula? K equal to Na plus into Cl minus divided by NaC. Now we will consider that NaCl have dissociated completely. So we will consider NaCl as 1. So what K equal to Na plus into Cl minus. Now if you know the value of K, or if you want to find out the value of K, like what is the constant value, so K equal to Na plus Cl minus. K, the value of K will be given to you in the numerical. Now Na plus also will be given to you, the concentration of Na plus. So you will be asked to find out the Cl minus. So how will you calculate the concentration of Cl minus? K by Na plus. So you know the value of K, you know the value of Na plus. From there you will calculate the concentration of Cl minus. So this law of mass action actually helps to determine the unknown concentration of the ions present in the precipitating solution. Clear?
Yes, ma'am.
Okay. Next, see, importance of solubility product. Same thing is written. It is useful for the calculation of the ion concentration if the other is unknown. That means you can calculate the unknown concentration of ions with the help of this solubility product. Solubility product means by applying law of mass action. One second, somebody wants to enter. Joydev Manna. Joydev Manna, you have entered just now. Joydev Manna.
No, ma'am.
You were there or you just got disconnected?
Disconnected, ma'am. A network problem.
Okay, okay. Next is the fractional precipitation. See, what is fractional precipitation? It occurs when precipitating reagent is added to a solution containing two ions. That means in a solution, two ions are already present, and to that solution, you are adding precipitating agent externally. For example, when silver nitrate is added to a solution containing both chloride and iodide. Okay. Now suppose in a solution both Cl minus ion is present and I minus ion is also present. And to that solution you are adding an external precipitating agent, that is silver nitrate. So silver nitrate, when you are adding silver nitrate, so it will react with Cl minus ion, leading to the formation of AgCl plus, and it will also react with the iodide ion, leading to the formation of AgI. So this process is known as the fractional precipitation. Clear or not?
Yes, ma'am.
Okay. Next, see factors affecting the solubility of precipitate. This is very important because question may come from this PPT. Okay, this is very, very important. So what are the factors that will affect the solubility of any precipitate? The first and foremost is the common ion effect. Again, this the term, the common ion effect, you have already studied in your physical chemistry, I hope so. So what is happening in the common ion effect? See, solubility of any salt can be decreased by adding an excess of either of its ion, and the precipitate dissolves more easily in water containing common ions. That means suppose in a solution Cl minus ion and I minus ion is present. Okay. Now, sorry, not I minus. Suppose in a solution Na plus ion and Cl minus ion is already present. You are adding excess of Cl minus again. Okay. So Cl minus ion is the common ion that you are adding. So what will happen? This Cl minus will have a tendency to get dissolved within the solution. So the more common ion more common ion effect will be produced, the more will be the chance of the dissolution of the precipitate. Next is the effect of pH. What is pH? How will you define pH? Anybody?
Negative logarithm of H plus.
Okay, very good. So how will pH affect the solubility of precipitate?
Inversely.
Solubility of precipitate increases, not inversely, directly proportional. Solubility of precipitate increases with increasing H plus concentration. That means as the pH will increase, the solubility of precipitate will increase. That means it is directly proportional. Temperature is again directly proportional. That means as the temperature will increase, the solubility of precipitate will also increase. Next is the effect of solvent. The solubility of precipitate is reduced by the addition of organic solvent. That means more the solvent you will add, less will be the solubility of the precipitate. And the last one is the effect of electrolyte. In case of electrolyte, precipitate is more soluble in electrolyte than water. That means if you add electrolyte, the solubility of the precipitate will more. That means it is directly proportional. So common ion effect, this is directly proportional because more the common ion you will add externally, more will be the solubility of precipitate. pH also directly proportional. As you will increase the pH, the solubility of the precipitate will also increase. Temperature is also acting directly proportional. That means as you will increase the temperature, the solubility of precipitate will also increase. Only the effect of solvent is inversely proportional. That is, more solvent you will add, less will be the solubility of the precipitate. And effect of electrolyte, more electrolyte you will add, more will be the solubility of the precipitate. So all the common ion effect of pH, temperature and effect of electrolyte is directly proportional. Only effect of solvent is inversely proportional. Any doubt?
No, ma'am.
Okay. Next comes the advantages, disadvantages and application of Mohr's method. You have already studied about the Mohr's method. So now we will see what are the advantages and disadvantages of this method. First advantages is it is simple as it does not consume time. It is a very simple method. So therefore in your lab, only this Mohr's method of titration has been chosen to be carried out, not Fajan's method or not any other's method. So this is a very simple method and it is not a time consuming method. Next, uses potassium chromate as an indicator which is easily accessible and affordable. That means potassium chromate, you can get potassium chromate indicator very easily in the lab. Okay, it is economical to buy potassium chromate. And the third is, it is a simple method, direct method and accurate method for chloride determination. So mainly remember, Mohr's method of titration is actually used for the determination of chloride ions. Okay, it is majorly used for the determination of chloride ions. You can also determine other halide ions by this method, but majorly, yes.
Ma'am, can we detect the pseudo halides like thiocyanate, isothiocyanate?
Mohr's method will not be a suitable method for that. For that, you have other two methods. We can use those.
Okay.
Okay.
Okay, ma'am.
Mohr's method is a very direct method. So in this, you will be able to determine any single direct ion properly. Next is the disadvantage. Now, what are the disadvantages? See, it is suitable only for the titration of chloride, bromide and cyanide. That means you will not be able to determine iodide ions by Mohr's method of titration. You can only determine chloride ions, bromide ion and cyanide ion. Okay? But if you want to determine any pseudocyanide ion, then it will be difficult by this method. Chances of error. Chances of error is more. Why? Because you are carrying out the titration procedure twice. First, you are carrying out for the standardization of the silver nitrate solution. So, there is a chance of error. More the process of titration, more will be the chances of error. And it requires neutral solution. That means in the like in other slide I have already taught you, like the solution should not be acidic, it should not be alkaline, it should be neutral. For carrying out the precipitation, Mohr's method of precipitation, the solution which you are using, that the pH should be neutral in nature. So if it is acidic or alkaline, then it will not give proper result. And application of Mohr's method, it is suitable for the titration of chloride ion, bromide ion and cyanide ion. So any doubt regarding this slide?
No, ma'am.
Okay. So next comes the Fajan's method. So I have taught like in the previous slide before Puja holidays, I have told you like we will study here 4 processes. One process is already over, that is the Mohr's method of titration. So now we will come to the second method, that is the Fajan's method of titration. Okay. Now what is Fajan's method of titration? See, in case of Fajan's method, we are using adsorption indicator. The type of indicator which is used in Fajan's method, that is known as the adsorption indicator. Okay, just remember the name because it may come in the MCQ, like name the indicator which is used in Fajan's method. Name the type of indicator. Now, if it comes name the indicator, then you have to name the particular indicator which is being used in the Fajan's method. But if the question comes, name the type of indicator which is used in the Fajan's method, that time you have to mention adsorption indicator. So the term adsorption indicator is very important. Next you see, adsorption of a colored organic compound on the surface of a precipitate may induce electronic shift in the molecule. That means, now what is this adsorption indicator? From the term adsorption indicator you can understand that in case of Mohr's method of titration, when you are adding potassium chromate indicator, the chemical reaction is actually occurring internally. Okay, the indicator is reacting internally within the solution. But in case of Fajan's method, when you are using adsorption indicator, the indicator is actually taking, the reaction of the indicator is actually taking place from the surface of the solution. It is not going inside the solution. It is on the surface of the solution, and that will help in the induction of electronic shift in the molecule. Okay, that's why it is termed as adsorption indicator. Since the indicator is acting on the surface of the solution and the chemical reaction is occurring from the surface of the solution, therefore the indicator is termed as the adsorption indicator. Now, due to the induction of the electronic shift in the molecule, that means when the electronic shift in the molecule is occurring, what is happening? There is a changes in the ionic concentration. The ionic concentration is also changing. That will lead to the alteration of color. This phenomenon can be used to detect the end point of precipitation titration of silver salt. That means you can titrate any silver salt by this Fajans method of titration. This method is also known as adsorption indicator method. So the other name for Fajans method is also adsorption indicator. And what indicator is used in this Fajans method? Here we are using fluorescein indicator. In case of Mohr's method of titration, we use potassium chromate indicator. In case of Fajans method, we are using fluorescein indicator. Now this indicator is an adsorption indicator. Now what is adsorption indicator? The indicator which will show its chemical reaction from the surface of the solution. That means it will not go internally within the solution. Okay. The difference between potassium chromate and fluorescein is that potassium chromate went inside the solution and it led to the changes in the ionic concentration. But here fluorescein indicator will remain on the surface of the solution and it will act from there. And being on the surface of the solution, it will lead to the changes in the ionic concentration present within the solution. That will lead to the change of color or alteration of color. Any doubt?
No, ma'am.
Next is the principle of Fajans method. When your next teacher will come, just let me know, okay? Because it is already 10:57, so maybe next is your inorganic chemistry class. Maybe Milan sir will come. So as soon as sir will come, please let me know. Joydev Manna? Joydev? Joydev, can you hear me?
Yes, ma'am.
Joydev, your connection is very unstable. Try to have a stable connection at your home, okay? Because every
Yes,
time
ma'am.
you are going disconnected, that means you are missing the topic which I am teaching you. So you are
Yes,
missing
ma'am.
the content. So try to have a stable connection at your home.
Yes, ma'am.
Next is the principle of Fajans method. Now, what is the principle? See, in aqueous solution, fluorescein dissociates to form positive hydrogen ion and negative fluoresceinate ion. That means the fluorescein indicator which you are taking as an adsorption indicator, when it is being added to the aqueous solution, that means on the surface of the solution, it is dissociated into positive ions and negative ions. That means positive hydrogen ion and negative fluoresceinate ion. Chloride ions are negatively charged ion. Now within the solution, fluoride ion is present. Fluoride ion is negatively charged in nature. Hence, what will happen? Hence, the negatively charged fluoresceinate ion will get repelled from the fluoride Cl minus ion. Negative will get repelled. Negative and positive will get attracted. Now, since Cl minus ion is present in more concentration than the positively, see in that solution, positively charged ion is also present and negatively charged ion is also present. But negatively charged ion is present in more concentration compared to that of the positively charged ion. So therefore, firstly, the negatively charged fluoresceinate ion will migrate towards the negatively charged fluoride minus ion. Now, since both are negatively charged in nature, so they will have a tendency to get repelled from each other. Therefore, fluorosinate ion will not attract the Cl minus ion. Now, hence due to this repulsion, it is producing a yellowish green color. Firstly, a yellowish green color is being produced. Now, a time will come, then what will happen? The Cl minus ion will finish from the solution. That means the content will decrease. Now, as soon as the content of or the percentage of the Cl minus will decrease, the positively charged ion, that is the Ag plus ion which is present in the solution, that will increase. Now, since Ag plus is positively charged in nature and fluorosinate ion is negatively charged in nature, so what will happen? There will be a attraction between the Ag plus and the negatively charged fluorosinate ion. So Ag plus and fluorosinate ion will get attract towards each other, and it will lead to the formation of a red color precipitate on the surface of the solution. Clear or not? In Fajan's method, we are using fluorescent indicator. Now, when we are dissolving fluorescent indicator in the aqueous solution, it is dissociating into H plus ion and negatively charged fluorosinate ion. Within the solution, both negatively charged particles as well as positively charged particles is present. But negatively charged particle is present in more quantity compared to the positively charged particle. Therefore, what will happen? This negatively charged fluorosinate ion will first collide with the negatively charged Cl minus ion. Now, since both are negatively charged, therefore, they will have a tendency to get repelled from each other. Due to this repulsion, what will happen? It will impart greenish yellow color solution. That means the color of the solution will turn greenish yellow color. Now, slowly, the concentration of the Cl minus ion will decrease within the solution and that of Ag plus ion will increase in the solution. So, the negatively charged fluorosinate ion will migrate towards the positively charged Ag plus ion. So, since Ag plus is positively charged and fluorosinate is negatively charged, so they will have a tendency to attract each other. As soon as this fluorosinate ion will get attracted towards the Ag plus, it will lead to the formation of a colored precipitate on the surface of the solution. So the major difference between Mongeau's method and Fajan's method is that the colored precipitate which is forming in the Mongeau's method, that is forming within the solution, and the colored precipitate which is forming in the Fajan's method, that is on the surface of the solution. That means on the top of the solution. Clear or not? Clear or not?
Yes, ma'am. Yes, ma'am. Clear.
Yes, ma'am.
Okay. Tomorrow maybe I won't be taking classes. Shweli madam will be taking class. So the next day, maybe Wednesday, if I take class, then I will continue with the precautions for the Fajan's method. Clear?
Okay, ma'am.
Up to this principle. I will not post any PPT now since I haven't completed the PPT to any material. Then you can go through the Mongeau's method of precipitation titration, which is already given to you. Okay, your third is waiting for your next class, and your attendance is already taken. I have already taken the screenshot of your attendance. Joydev Manna, I don't know whether you are there or not when I have taken the screenshot, but you just ping me in the WhatsApp, okay, regarding your attendance so that I can remember it. Joydev, are you listening?
Okay, ma'am. Okay, ma'am.
Okay. Milan sir, are you there? Milan sir? Milan sir? Milan sir?
Hello.
Sir, are you there?
Yes, yes.
Okay, sir, I'm making you host.
Is there? What about Na2CO3? Na2CO3 is not a Lewis acid or Lewis base because during dissolution of Na2CO3 in water, it produces a strong base NaOH and a weak acid of H2CO3. And that's why Na2CO3 is considered as a base, but not Arrhenius base or Lewis base. Am I right? Why Na2CO3 is considered as a base? Hello? Somo?
ইনঅর্গানিক হচ্ছে এটা।
Am I audible?
Yes, sir.
So why Na2CO3 is considered as a base? When Na2CO3 is dissolved in water, it dissociates into two different kind of substance. One is strong base NaOH and weak acid Na2 and weak acid H2CO3. As it produces the strong base or the solution contain OH minus ion, that's why it is considered as a base. And I also discussed in my previous class the limitation of Arrhenius concept of acid and base, and where we discussed the definition of acid and base are not confined within the aqueous solution. That means few substance or few acidic or basic substance, they possess their acidic or basic properties in organic solvent also. And there was no clear-cut idea about the BF3 and LCl3. Why BF3 and LCl3 is considered as an acid is not described by the Arrhenius concept. Likewise, the neutralization reaction may also occur in the solid state as well as organic solvent. But in Arrhenius concept, the neutralization reaction only occur where in Arrhenius concept, where he described that the neutralization reaction mainly occur in the aqueous solution. But neutralization reaction may also occur in the solid state as well as organic solvent. This concept is also not explained by the Arrhenius concept. So these are the five different points, and these points are not clearly explained by the Arrhenius theory. Next, what about HSO4 minus? Regarding Bonsted-Lowry concept, HSO4 minus is an acid or HSO4 minus is a base? What about HSO4 minus?
Acid, sir.
So it may consider as an acid and base both, because it can either accept an H plus ion to produce H2SO4, or it may donate the H plus ion to convert into SO4 2 minus ion. So this is HSO4 minus is an acid and base both according to Bonsted-Lowry concept. As acid is a proton donor and base is a proton acceptor, that's why HSO4 minus can receive one H plus ion to convert into H2SO4. And at that time, we can consider HSO4 minus is an acid. But in aqueous solution or in presence of a base, HSO4 minus can donate H plus ion. Thus, according to Bonsted-Lowry concept, HSO4 minus can be considered as an acid and base both. Am I right or wrong?
Right, sir.
Okay. Next one, why BF3 and AL3 are Lewis acid, that are already discussed. Next one, ammonia is considered as a Lewis base. What is adduct? So adduct formation only possible when a Lewis acid is combined with a Lewis base. So during reaction of ammonia with the BF3, the lone pair electron of nitrogen atom of ammonia can easily donated to the boron atom of BF3. So there may be a formation of a directional bond or coordinate bond. So coordinate bond containing a Lewis acid and Lewis base that are present within the parenthesis or third bracket, this complex is considered as a adduct. or this complex may also known as a coordinate complex. So coordinate bond formation is essential during neutralization reaction of a Lewis acid and Lewis base. These are explained by the Lewis concept, but that may not occur always. During reaction of a Lewis acid and Lewis base, there may be a formation of a coordinate bond containing molecule or coordinate complex or adduct. It is not always possible. So this is one of the disadvantage of the Lewis concept. Next one, suppose one organic molecule X, which is a Lewis acid, and another organic molecule Y, which is considered as a Bonsted-Lowry acid. So which of the following most accurately describes the similarity in their behavior in solution or behavior in aqueous solution? So which one was the correct? A, B, C, D মধ্যে?
D. C. C.
Why C? X is a Lewis acid. C is the correct answer because X is a Lewis acid. That means X receive a lone pair electron from the other molecule within a aqueous solution. So it receive one lone pair electron. That means X become X minus, and Y is a Bonsted-Lowry acid. That means it provide an H plus ion to the other. So after providing the H plus, Y become Y minus. So both of them get converted to the negatively charged ion within the aqueous solution. And thus C is the correct answer. Okay. Next, what is the conjugate acid base pair? Now, in each acid base reaction, there is a formation of two pairs of acid base conjugate by the mutual transfer of proton. Here one example, HCl when react with the water, HCl provide one H plus or proton to the water molecule. That's why water molecule converted to the hydronium ion H2 plus. So HCl and Cl minus is a conjugate acid base pair, and water and H2 plus is another acid base conjugate. So in each acid base reaction, there may be two pairs of acid base conjugate, and each pair of acid base conjugate differ from each other by one proton. Now, according to this concept, we may consider H2SO4 is a dibasic acid. That means it initially converted to HSO4 minus, and this HSO4 minus further converted to the SO4 2 minus ion. And where H2SO4 and HSO4 minus is a conjugate acid base pair, or HSO4 minus is the conjugate base of H2SO4, or HSO4 minus is also a conjugate acid of SO4 2 minus ion. So next question is, so what is the conjugate acid of HPO4 2 minus? Answer please. What is the
Option A, sir.
why your option is? That means for the preparation of conjugate acid, we need to add one H plus ion. That means H2PO4 minus is the conjugate acid of HPO4 2 minus. That are also previously discussed. Next one, as per the Lewis concept, a molecule in which the central atom has an incomplete octet is dash. What is the another name of the compound which has an incomplete octet, or molecule which is electron deficient in nature? Which one is the correct answer? Acid or base? Acid.
Acid.
Next question, which of the following species can act as a Lewis base? Which one is the correct answer? A, B, C, D. Which of the following species can act as a Lewis base? Lewis base means they are the negatively charged ion, or simply they are the anion, or they may be a neutral molecule containing a lone pair electron. That's why option 1 is the correct answer. Okay. Next. Type of solvent with their example. there are three different kind of solvent. Protogenic, that means they are the acid. Protophilic, that means they can receive the proton or proton loving. Amphiprotic solvent means they can either donate or accept a proton from the other molecule. As for example, water can behave as a both protogenic and protophilic solvent. In presence of acid, water acts as a proton acceptor.
Sir,
Yes.
is that photophilic or protophilic?
Proto. There is a problem. PHO. That will be PROT.
PROT. Oh, okay. Thank you.
Protogenic, protophilic, and amphiprotic. So one more question: why water acts as a amphiprotic solvent? Because water can receive H plus in presence of acid, or it can donate the H plus ion to the base.
Load better did
Hello? Have any doubt?
No, sir. No, sir.
So on the basis of proton donor and proton acceptor, so water acts as the amphiprotic solvent or simply a protic solvent. So next question, what are the protic solvent? Solvent that can accept as well as donate the, that are the protic solvent. And one best example of the protic solvent is the water, or protic solvent also known as the amphiprotic solvent. Next question, what are the aprotic solvent? Mostly the organic solvent are the aprotic in nature, as because of their lack of, or they have a less tendency to generate the H plus ion. So what are the aprotic solvent? Solvent that can neither accept nor donate the proton. So answer D is the correct answer regarding aprotic solvent. Okay. What are aprotic solvent? Answer D is the correct answer. Next one, where we can simply describe the substance which are strong acidic in nature has a weak conjugate base. As for example, HCl is a strong acid as it dissociates completely within the aqueous solution, but its conjugate base, that is the Cl minus, is a weak conjugate base. But in case of methane, so methane is a weak acidic substance and its conjugate base CH3 minus is a strong conjugate base. So in this slide, one can easily predict the strength of an acid as well as its conjugate base. Next slide, I also discuss about the pH. I think all of you are very well aware about this matter. What is Kw? Kw is the ionic product of water, and value of Kw is 1 into 10 to the power minus 14 at 25 degrees centigrade. But temperature mention is very essential, because with the change of temperature, the value of Kw will change. So next, question is there. Question number 1, calculate the hydroxyl ion concentration and pH of a solution containing 490 gram of sulfuric acid in 50 liter of aqueous solution. So try to solve this one. Question 1, calculate the hydroxyl ion concentration and pH of a solution containing 490 gram of sulfuric acid in 50 liter of aqueous solution. So how can we calculate it? First step, we need to calculate the mole of sulfuric acid. Step 1, calculate the mole number of sulfuric acid. Here 490 gram sulfuric acid given. So 490 divided by 98 is equal to 5 mole of sulfuric acid present in 50 liter of aqueous solution. So 5 mole sulfuric acid in 50 liter of aqueous solution. That means molarity of the solution will be 5 by 50. Am I right? So molarity of the solution is 5 by 50. Anwar Hussain. Anwar. Sulfuric acid is equal to 5 mole. Molarity of the solution will be 5 by 50. That means 10 to the power minus 1 molar solution. Thus the concentration of H plus become 10 to the power minus 1 and pH will be 1. So concentration of OH minus ion will be 10 to the power minus 14 divided by 10 to the power minus 1. That is 10 to the power minus 13 is the hydroxyl ion concentration and pH of the solution will be 1. Okay, is there any problem for question number 1? pH will be 1 and hydroxyl ion concentration will be 10 to the power minus 30. Next question, what is the conjugate acid and conjugate base of HSO4 2 minus ion? What is the conjugate acid of HSO4 2 minus? Please respond.
H2SO4 and SO4 2 minus.
H2SO4 and H2SO4 and SO4 2 minus. What is the concentration of hydroxyl ion of a solution having pH 6? Question number 3. pH is 6, but you have to calculate the concentration of hydroxyl ion. As pH is 6, that means concentration of H plus is 10 to the power minus 6. And H plus is equal to 10 to the power minus 6. That means concentration of OH minus is equal to 10 to the power minus 14 divided by 10 to the power minus 6 is equal to 10 to the power minus 8. 10 to the power minus 8 is the hydroxyl ion concentration and 10 to the power minus 6 will be the concentration of H plus ion. Okay, is there any problem? Question number 3, regarding question number 3. No problem, yeah? Kw of a water is 10 to the power minus 13. Compute the sum of pOH and pH of a neutral aqueous solution. So what will be the answer? Kw for water is 10 to the power minus 13. And what is the sum of pOH and pH? Which one is the correct answer?
13.
13 is the correct answer. Yes, 13 is the correct answer. Next question, 10 to the power 5 molar NaOH solution at 25 degrees centigrade is diluted 100 times. So pH of the resultant solution will be equal to 8 or lie between 7 and 8 or lies between 6 and 7 or remain unchanged. Upon dilution 100 times for 10 to the power 5 molar of sodium hydroxide solution. Which one is the correct answer? So during dilution, the concentration of OH minus ion
Not change, sir.
Why not change? If it is diluted 100 times, their concentration of OH minus become more, or become less. 10 to the power minus 5 divided by 100. That means concentration of OH minus become 10 to the power minus 8. And concentration of OH minus become 10 to the power minus 8. Thus concentration of H plus become 10 to the power minus 6 As it is a basic solution, so the pH become more than 6. It will never less than 6 or lies between 6 to 7. Answer C is the correct answer. 10 to the power 5 molar NaOH, that means its content 10 to the power 5 molar OH minus ion. Upon dilution, its concentration become 10 to the power minus 5 divided by 100. That is 10 to the power minus 7 is the actual concentration. 10 to the power minus 7 is the actual concentration of OH minus. So there is a mistake. B is the correct answer. pH lies between 7 to 8. As OH minus ion concentration 10 to the power minus 7. So H plus ion concentration become 10 to the power minus 7. And as it is a basic solution, the pH must be higher than the 7. So lies between 7 to 8. So B is the correct answer. Is there any problem?
No, sir.
Next one, pH of a solution is 5. And to this solution, an acid was added so that its pH value become 2. The increase in H plus ion concentration is pH, previous pH was 5 and next it changed to the pH 2. So how many folds of H plus ion concentration change? So previously its pH is 5, that means H plus ion concentration is 10 to the power minus 5. And next its pH is 2. So concentration of H plus ion become 10 to the power minus 2.
100 times.
No, 10 to the power minus 5 divided by 10 to the power minus 2. That means 1000 times.
1000.
1000 times is the correct answer. So change of pH 5 to 2, that means 100 times change of H plus ion concentration. Next one, equal volume of 2 HCl solution having pH 3 and pH 5 are mixed. So what is the pH of the resulting solution? So we need to calculate the H plus ion of this mixture. So first solution has a pH 3, that means which H plus ion is 10 to the power minus 3. And in second solution, concentration of H plus is 10 to the power minus 5. Now we need to calculate the molarity of the final mixture. So what will be the molarity of the final mixture? That may be calculated by the using formula M1 V1 plus M2 V2 is equal to M into V1 plus V2. So final M become 5. Final molarity of the mixture will be 5.5 into 10 to the power minus 5. Okay. 5.5 into 10 to the power, final molarity of the mixture will be 5.5 into 10 to the power minus 4. So correct answer will be 3.3. Negative log of 5.5 into 10 to the power minus 4 will be 3.3. All of you need to calculate this one. This is important for your first slot exam. Correct answer is D, 3.3. So hydrogen ion concentration 10 to the power minus 5 plus 10 to the power minus 3 divided by 2, that is 5.5 into 10 to the power minus 4. So pH is equal to negative log of 5.5 into 10 to the power minus 4 is equal to log of 10 to the power minus, negative log of 10 to the power minus 4 is equal to 4, and negative log of 5.5 is equal to 0.7. So final pH will be 3.3. Next one, The hydrogen ion concentration of ocean is about 2 into 10 to the power minus 9 molar. What is the pH? Please work out this problem. So we need to calculate ocean have hydrogen ion concentration 2 into 10 to the power minus 9. So pH will be negative log of 2 into 10 to the power minus 9. So log 2 is the 0.301 or simply 0.3. So 9 minus 0.3 is the actual answer. That is answer D. 8.7 is the correct answer. Next, what is buffer? Now buffer usually a mixture of two different chemical substance or a solution which has a capacity to resist the change of pH upon addition of small amount of acid or base. So all buffer solution has a capacity to resist the change of pH. There are two different kind of buffer. One is acidic and another one is the basic buffer. Acidic buffer is the mixture of weak acid and it's salt with a strong base. As for example, CH2COOH
एक्स्ट्रा टाइम के लिए देखिए आप दोनों कंडम सेम है, दोनों ही कंडम एक्स्ट्रा टाइम है और दोनों के बारे में पूरी डिटेल पीछे डिस्प्ले कर रखी है कंपनी ने। इसमें बस इनमें डिफरेंस है, वो आप देख लीजिए। इनमें डिफरेंस इन्होंने दिया है कि एक तो इसका शेप अच्छा है और इसमें थोड़े से डॉट्स और रिप्स भी है साथ में। तो पूरा कंडम खोल के देख लेंगे दोनों कंडम को और अपन डिसाइड कर लेंगे कितना फर्क है दोनों में। उसके बाद आप डिसाइड कर सकते हैं क्योंकि आपको कॉस्ट ज्यादा देनी है। अब इसकी कॉस्ट है 228 रुपए और इसकी कॉस्ट है 330 रुपए, तो काफी ज्यादा 100 रुपए का डिफरेंस है 10-20 के पैक में। तो डिफरेंस क्यों देना है आपको, क्यों डिफरेंस इसका इतना ज्यादा है देख लेते हैं। क्योंकि दोनों में एक्स्ट्रा टाइम का लुब्रिकेंट भी है, दोनों ही सेम कंपनी के हैं, दोनों ही कंडम्स की फिटिंग भी अलग अलग तरीके थोड़ी, तो ओपन करके देख लेते हैं। उससे पहले हमारे चैनल को सब्सक्राइब
Hello.
Yes, sir.
So all of you are there. Actually, you need to help us to detect the student. Okay, try to take one. এরকম প্রবলেম করলে তো ক্লাস নেওয়া যাবে না, তাই না? তোমাদেরকে ডিলিট করতে হবে না। সবাই তোমরা বসে থাকে তাহলে ডিলিট করতে পারবো না, কারণ এখানে আমি চেষ্টা করলাম কিন্তু ডিলিট করতে পারিনি। কে এসব করছে? তোমাদের মধ্যে কেউ একজন স্ক্রিনশটটা যে ক্লাসে নিয়ে রাখবে, আমাকে একটু পাঠাবে, পারবে? অনির্বাণ আছো?
হ্যাঁ স্যার আছি। ইয়েস স্যার।
স্ক্রিনশটটা নিয়ে আমাকে আগের দিনের মধ্যে পাঠিয়ে দিই। হ্যাঁ
আচ্ছা স্যার, ঠিক আছে।
ঠিক আছে, আমি ক্লাস কন্টিনিউ করছি। অ্যাসিডিক বাফার, example of acidic buffer is the mixture of acetic acid and its salt with a strong base, that is sodium acid. Likewise, basic buffer is also prepared by the mixture of weak base and its salt with a strong acid, as for example NH4OH and NH4Cl. So another few example of acidic buffer are mixture of carbonic acid and sodium bicarbonate, mixture of phosphoric acid and sodium dihydrogen phosphate or mixture of formic acid with sodium formate. So how can we detect a mixture? This is a acidic buffer or basic buffer. Now when we see that the mixture contain any weak acid and its conjugate base, then we can consider the mixture is a buffer or which has a capacity to resist the change of pH. So all the acidic buffer is a mixture of weak acid and it's salt with a conjugate base or it's salt with a strong base. So another one example is the double salt buffer. Phosphate buffer is a double salt buffer because it consists of two different kind of salt, not weak acid or weak base. Phosphate buffer is a mixture of disodium hydrogen phosphate or dipotassium hydrogen phosphate along with potassium dihydrogen phosphate. So phosphate buffer is made by two different kind of salt, monobasic potassium phosphate or dibasic potassium phosphate or potassium dihydrogen phosphate K2PO4 or K2HPO4. Next, how buffer resists the change of pH or what is the buffer action? To explain the buffer capacity or buffer action, we need to take one acidic buffer or mixture of CH3COOH and CH3COONA, and within aqueous solution, acetic acid is dissociated to produce H plus and CH3COO minus. Likewise, CH3COONA is also dissociated to produce Na plus and CH3COO minus. So both the substance after dissociation produce CH3COOH, and this CH3COOH is the common ion. And this common ion prevents the dissociation of both CH3COOH and CH3COONA. And this is known as the common ion effect. Here, CH3COO minus is the common ion, and which prevents the dissociation of both CH3COOH and CH3COONA. Thus, the concentration of H plus or concentration of other ion within the mixture is always constant. And common ion effect is the principal concept to resist the change of pH. Next, when we add small amount of acid to a buffer, that means after addition of HCl, there may be a generation of extra H plus ion, and this extra H plus ion is consumed by the common ion present within the buffer solution. Upon addition of HCl, the additional H plus ion is consumed by the CH3COOH. So there is no change of pH upon addition of HCl. Likewise, after addition of NaOH to the aqueous solution, NaOH also generates an extra amount of OH minus ion, but this extra amount of OH minus ion is neutralized by the H plus that are already exist within the buffer solution. Thus, upon addition of HCl or NaOH, there is no change of pH, and this is the buffer action. The buffer has a capacity to consume the extra H plus and OH minus ion if it is present within the aqueous solution. So there is no change of pH upon addition of acid and base or small amount of acid or base. This is the buffer capacity. Next, so how can we calculate the pH of a acidic buffer solution? So during calculation of pH, we need to take a acidic buffer H. Upon dissociation of HA, it produces H plus and its conjugate base A minus ion. So HA is a weak acid. Its acid dissociation constant Ka, it can be easily calculated by the K equal to concentration of H plus into concentration of A minus divided by concentration of weak acid HA. So from where we can calculate, we need to calculate the pH. That's why H plus is taken in the left hand side of the equation. H plus is equal to K into concentration of HA, that means weak acid, divided by its conjugate base A minus. So upon addition of negative log on both sides of the chemical equation, we can easily calculate the pH equal to pK minus log of HA. That means log of weak acid divided by its conjugate base, or pH equal to pK plus log of conjugate base by acid is the Henderson-Hasselbalch equation for calculation of the pH of acidic buffer. Okay, any problem? This is also important for your first lot exam. Derivation of pH for acidic buffer. So next few question, when pH equal to pK?
Excuse me, sir. Will you share your screen?
Oh, yeah, screen is not there.
No, sir, it's not there.
No, sir, you are already sharing it. We can see it's visible to us.
Sharing.
Sir, your screen share is visible to us. You are already sharing the screen.
Okay. This is visible.
Yes, sir.
Yes, sir. Now it's visible.
So few more questions during discussion of pH of acidic buffer or calculation of acidic buffer by Henderson-Hasselbalch equation. Few more question is there when pH equal to pK. As we know that pH equal to pK plus log of conjugate base by acid. So if 50% of HA, that means weak acid, is dissociated in aqueous solution, then 50% of conjugate base appear within the aqueous solution, then log of A minus by HA become 0. That means pH equal to pK. Or when 50% of the acid is dissociated in aqueous solution, then concentration of weak acid and its conjugate base become equal, and at that time pH become equal to pK. Am I right? When pH equal to pK, when 50% of weak acid is dissociated within the aqueous solution, or when concentration of weak acid and its conjugate base is equal, then pH equal to pK. And at that particular time, when pH equal to pK, the buffer capacity of the buffer solution is maximum. So when the buffer capacity is maximum? Now when pH equal to pK, or when 50% of the weak acid is dissociated, or when concentration of weak acid is equal to the concentration of its conjugate base, then pH of a buffer solution of pH is equal to pK and its buffer capacity become maximum. One more question, how can we change the pH of a buffer by 1 unit? How can we change the pH? Because it a 10-fold change in the acid concentration, pH of the buffer solution is decreased by 1, or 10-fold decrease of acid concentration, that means pH of the buffer solution increased by 1, or pH equal to pK plus 1. When pH equal to pK plus 1, or 10-fold increase of concentration of the acid. Okay, anybody have any problem for this 3 question, when pH equal to pK, or how can we change the pH of the buffer? Bolo.
Sir, 10 folds mean বাংলাতে?
10-fold means 1 লিটার সলিউশনকে যদি 10 লিটার বানিয়ে, 10 লিটার সলিউশনকে 1 লিটার তো বানাতে পারবে না, এটা কে বোঝে?
Okay, sir.
So 3 more question is there. pH equal to pK, how pH change by 1 unit, or when the buffer capacity is maximum? When buffer capacity maximum? Now when pH equal to pK, or 50% of the weak acid is dissociated, or where concentration of weak acid and its conjugate base is equal. Next, which is the strongest acid? And pK value given in the parenthesis. Which one is the strongest acid?
Sir, D.
D is the why D?
No, sir, it's E.
C.
The substance which has a higher K value
Sir,
is the
E.
correct answer.
and lowest pK value is the strongest acid. Highest
sir, E.
K and lowest pK has stronger acidic in nature. So the answer A is the correct.
What?
Okay. K value is maximum and pK value will be minimum. Then the acid will be the strongest acid. The answer A is the correct answer. A is COOH, which has pK value 3.77. Correct? So,
Yes, sir.
so what is the buffer capacity? Buffer capacity, the amount of acid or base required to add in 1 liter of buffer solution to change its pH by 1 unit. The amount of acid or amount of base required to add in 1 liter of a buffer solution to change its pH by 1 unit. This is the buffer capacity. So value of buffer capacity is always positive. Why? Now both dB, that means small change of the buffer concentration, or small dpH is the small change of pH. Both of them have the same sign. That's why buffer capacity is always positive. And here we show one buffer capacity versus pH plot. And by this graphical representation, we can easily calculate the pH at which the buffer capacity maximum. Here, by interpolation technique, the buffer capacity maximum at 1.7 and where the pH is 4. By interpolation or extrapolation technique, from a buffer capacity plot, we can easily calculate the maximum buffer capacity of a particular buffer. So, from the above graphical equation, we can easily calculate the buffer capacity at any pH and can also capable to calculate the maximum buffer capacity by inter and extrapolation technique. At pH 4, the buffer capacity is 1.7. That are also calculated by extrapolation or interpolation technique. And it is obvious that the buffer capacity is reasonably high only for the pH close to the pK value. For any buffer system where the pH and pK is very nearer to each other, that means the buffer capacity of this solution is maximum. And next one point, a solution containing only a conjugate base have a buffer capacity 0. So 3 or more important information is there. One is buffer containing only conjugate base has a buffer capacity 0, and the buffer which has pH value nearer to pK value has maximum buffer capacity. And for graphical representation or from a graphical representation, we can easily calculate the buffer capacity of a solution for its individual pH. For any pH, we can easily calculate the buffer capacity. So what kind of information is provided by a buffer capacity versus pH plot? This is a one important question for your first lot exam. What kind of information is provided by the pH and buffer capacity plot? And these are 4 different information. So calculation, next point is the calculation of pH of a basic buffer. So for calculation of a pH of basic buffer, we need to take a weak base, that is BOH, and BOH upon dissociation produce a conjugate base OH minus, and from where we can easily calculate the Kb or base dissociation constant for weak base BOH, and from where we need to calculate POH because H plus is absent here. So only we need to calculate the concentration of OH minus ion, and thereafter by taking the negative log on both sides of the previous equation, OH minus is equal to Kb into BOH by B plus, where we take negative log on both sides of the equation, and thereby we can easily calculate POH equal to PKB minus log of BOH divided by B plus. This is also a Henderson-Hasselbalch equation, and from where we can easily calculate the pH. We have to mistake it. The pH equal to POH equal to PKB, where pH equal to, this is incorrect, POH equal to PKB plus log of conjugate acid by base. As we know that the pH equal to POH equal to 14, that means pH is calculated by P 14 minus POH or 14 minus PKB plus log of conjugate acid by base. Next few information, if we consider for a basic buffer NH4Cl plus NH4OH, where NH4Cl is a salt of strong acid. That's why NH4Cl can completely dissociate within the aqueous solution, but NH4OH is slowly dissociate or generate less amount of NH4 plus and OH minus. Thus the total concentration of NH4 plus, that is the conjugate acid, or concentration of NH4 plus is equal to the concentration of NH4Cl. Thus the previous equation, that is pH equal to 14 minus PKB plus log of conjugate acid by base, can be changed as pH equal to 14 minus POH or 14 minus PKB plus log of NH4Cl by NH4OH. As concentration of NH4 plus is equal to the concentration of NH4Cl. So final equation is the pH equal to 14 minus within second bracket PKB plus log of salt by base Next, what is the significance of Henderson-Hasselbalch equation, by which we can easily calculate the pH of a buffer solution, or Kb, Kw, if we know the value of H plus and OH minus ion concentration. Next one question, calculate the pH of a buffer solution containing 0.03 mole or 0.03 molar acetic acid and 0.1 molar sodium acetate, having pK value of acetic acid 4.57. So how can we calculate the pH? See, information is given. Concentration of weak acid is 0.03. Concentration of salt or sodium acetate is equal to 0.1 and pK value is 4.57. So by using this is a acidic buffer, mixture of acidic buffer. That's why we can easily calculate the pH by using pH equal to pK plus log of salt by acid or conjugate base by acid. So final mixture has a pH 5.09. বলো কিছু ডাউট আছে এখানে? সিম্পল কোশ্চেন, সব ডেটাগুলো এখানে দেওয়া আছে। ডেটাগুলো শুধু হেন্ডারসন-হেসেলবেগ ইকুয়েশনে পুট করব। pK value given, concentration of salt and concentration of acid also given. Henderson-Hasselbalch equation, and initially we have to predict which Henderson-Hasselbalch equation is used for the calculation of pH. As it is a mixture of acidic buffer, that's why we use the equation Henderson-Hasselbalch equation for acidic buffer only. Next one, calculate the pH of a buffer solution containing 0.25 molar formic acid and 0.1 molar sodium formate, where Ka value given. So at first we need to calculate the pK value by taking the negative log of K. That means pK equal to negative log of 1.8 into 10 to the power minus 4, by which we can easily calculate the pK. And another two information is given: salt concentration 0.1 molar and acid concentration is 0.25. Thus, by applying the Henderson-Esselstyn equation, we can easily calculate the pH of the acidic buffer. That is, pH equal to pK minus log of salt by acid. Another one, how can we prepare the buffer solution having a pH? This is also important for our laboratory purpose. How can we prepare the buffer solution of pH 5 from acetic acid, sodium acetate, and having the pK value of acetic acid is 4.7. So how can we prepare? This is also a acidic buffer solution where pH given, concentration of salt and concentration of acid not given here. So at first we need to take the molar concentration of acetic acid is 1 molar and molar concentration of the base required is x molar, where pH given 5, pK also given 4.7. So by applying Henderson-Esselstyn equation, we need to calculate the value of x. So molar concentration of acid taken 1 molar and molar concentration of base, that is x, is calculated as 2. So by this information, when we take 1 molar acetic acid is mixed with 2 molar of sodium acetate in a 1 liter solution, the final pH of the solution become 5. So what is the problem? Is there any problem? How can we prepare the acidic buffer or mixture of acetic acid and sodium acetate buffer of pH 5 molar by using acetic acid, sodium acetate, where the pK value of sodium acetate 4.7. বলো কার কিছু প্রবলেম আছে এটা নিয়ে? ফাইনাল কি অ্যান্সার এলো? যে 5 মোলার একটা অ্যাসিডিক বাফার বানাতে গেলে 1 মোলার অ্যাসিটিক অ্যাসিড 2 মোলার সোডিয়াম অ্যাসিডেটকে মিক্স করব 1 লিটার জলের মধ্যে, তাহলে যে সলিউশনটা তৈরি হবে তার pH হবে 5। কি প্রবলেম আছে বলো অনির্বাণ? অনির্বাণ, হ্যালো?
ইয়েস স্যার।
স্ক্রিনশটটা নিয়েছো ওটা?
হ্যাঁ নিয়ে নিয়েছি স্যার।
ওকে ওকে, ওটা তাহলে পরে আমাকে সেন্ড করে দিও। বলে
আচ্ছা
কোশ্চেনে কোনো প্রবলেম আছে যে pH যখন 5 মোলার অ্যাসিডিক বাফার সলিউশন বানাতে বললে আমি কিভাবে বানাবো, ল্যাবে কি করে বানাবো, অথবা তার এই ক্যালকুলেশনে কি প্রবলেম আছে? না অ্যাজিউম করে নিয়েছি যে কনসেন্ট্রেশন অফ অ্যাসিড নিয়েছি 1 মোলার, so what should be the concentration of the base? So concentration of base is taken as x molar, and by mathematical calculation we need to calculate the value of x. X is 2 molar of base. So upon mixing of 2 molar of sodium acetate and 1 molar of acetic acid within 1 liter of solution, we can easily prepare a buffer solution having pH 5. Next, properties of an ideal buffer. So what should be the properties of an ideal buffer? Point number 1, the buffer should not